All right, let's talk about one of the universe's most fundamental rules. I mean, this is a core principle in physics that explains just about everything, from car crashes all the way to rocket launches. We're going to dive into the law of conservation of momentum. But before we get all technical, let's start with a question you've definitely seen a million times in movies. Why does a gun kick back so hard when you fire it? I mean, it's a really powerful, sudden reaction. What is actually going on there? Well, stick with me because the answer is honestly pretty cool. The whole secret is something called the law of conservation of momentum. Now, the official definition sounds a little dense, but it's simple. It says that in an isolated system, which basically just means a situation where no outside forces are messing with things, the total amount of momentum you have before an event is the exact same as the total amount you have after. Nothing gets lost, nothing is created out of thin air, it just gets moved around between the objects. Let's really let that sink in, because this is the golden rule. It doesn't matter if it's two things crashing into each other or one thing exploding into a bunch of pieces. The universe keeps a perfectly balanced set of books. The total momentum you start with has to equal the total momentum you end up with, period. So how do we actually keep track of all this? Well, with a little bit of math, of course. Let's take a look at the equation that shows us how it all adds up. Okay, so just picture this. You've got two objects, we'll call them mass 1 and mass 2, and they are headed right for each other. Now, each one has its own momentum. You get that by multiplying its mass by its velocity. Before they hit, the total momentum is just what you get when you add their two individual momenta together. Simple enough, right? And then, bam, they collide. Now, after that impact, their speeds are totally different. Maybe one is going slower now and the other one is going faster. But, and this is the absolute key, if you add up their new momenta, the total amount is exactly what it was before they ever touched. The momentum was conserved.
And this formula, this is just the fancy math way of saying exactly that. On the left side, you've got the total momentum before the crash, and on the right, you've got the total momentum after. That little equal sign in the middle is really the star of the show. It tells us that both sides have to be perfectly balanced, no matter what.
Okay, theory is cool and all, but let's bring this back to that first question we had. How does any of this explain the kick of a gun? Let's take this law and apply it to our explosive example. So you can think of firing a gun as sort of a collision in reverse. It's an explosion. So we've got two states to look at. Before you pull the trigger, the gun and the bullet are just sitting there, perfectly still. Then, after you fire, they fly apart in opposite directions. The physics has to make sense of both situations. And here is the most important piece of the puzzle. Before the trigger is pulled, what's the total momentum of that gun and bullet system? Well, it's zero. A big, fat zero. Nothing's moving. So that number, 0, is our starting point. Now think about what happens after you fire. The law says the total momentum still has to be 0. But how is that possible? You've got a bullet screaming forward with a massive amount of momentum. Well, to keep everything balanced at 0, the gun has to create an equal and opposite momentum by flying backward into your shoulder. The bullet's forward momentum and the gun's backward momentum perfectly cancel each other out. And that kick, that's recoil. That's the conservation of momentum in action, right there.
This isn't just a neat trick for guns and car crashes. This is a truly universal law. It governs everything from billiard balls clacking on a table to how entire galaxies interact with each other. It's a fundamental piece of how our world is put together.
So what are the big takeaways here? First, momentum is always conserved when outside forces aren't involved. Second, that just means what you start with is what you end with. And finally, this one simple rule is powerful enough to explain both why things bounce off each other and why they kick back. Honestly, if you remember just one thing from all of this, let it be these 3 words. Momentum is conserved. It's a non-negotiable rule of the universe. So I'll leave you with this thought. Now that you know the rule, where else do you see it? Think about a game of pool, the crack of the brake, or think about how a rocket pushes itself into space by throwing exhaust out the back. This law is absolutely everywhere. What are you going to see differently now?